It sounds pretty identical. Hey, I'm Dave Otero. Welcome to this Mix Lab, where we're going to give you a quick overview of a new open source plugin called Neural Amp Modeler. So it's definitely been making some waves in the community lately, the online music community, as it were. And it's a very cool thing that has finally come to an all-in-the-box solution. So it essentially does kind of what a Kemper does, where you can take an amp, an amplifier, typically guitar amps, but honestly, it can be used with many different sources, capture its tone in a processor we're going to go over, and then recall it with a file, in this case, a model of that particular amplifier, and have an extremely close representation of that guitar tone or preamp tone or saturation tone. It's really a pretty capable piece of software. Just like a Kemper, it can't handle time-based effects, so you can't like clone a delay or necessarily a compressor. But anything with a distortion characteristics, saturation characteristics, overall EQ characteristics, it does a pretty good job. So here we can see the plugin. I've just got it loaded up. There's no model, no IR loaded. It just looks like an amp sim. It does give you control over a gate, your input, output volume, and a really kind of quick tone stack EQ. It has a normalize function to normalize between different models, which can be handy. And then you obviously can pick your model and load an IR directly in the plugin. But we're going to start from the beginning, take you through the process of capturing a tone, training a tone, because this is actually using machine learning, which is just kind of insane. Training that model, pulling that model back in and loading it up and comparing it to your original source. So let's get out of this. And for our source, going to use a plugin, just because it's a little easier to do in the box here. But you can absolutely use this with a guitar amp, and I have many times, and it sounds great. I've modeled full, somewhat mixed bass tones before that use a combination of plugins and EQs and all kinds of processors in a mix, and it does a pretty fantastic job of that. Kind of the advantage that it may have over a Kemper, well, there's many advantages, but I'll go over a few. One, it's all in the box. Two, it's free at this time and point. And three, it allows you to separate the capturing and the training process. So if you make a model using a Kemper, you have to have everything set up at the same time. All the sources feed back into the Kemper. You hit a button, it sends its capture source out through the amp, back in through the Kemper, all at the same time, and then your model spits out. But you couldn't quite just like reamp a source and then deal with the rest of it later, which you absolutely can using Neural Amp Modeler, which is why it's so convenient. So before we get into that, one thing at a time, this is a confusing topic, so I am doing my best to make this somewhat palatable for you guys. But as you'll see when we get into it, it's very much open source. If you've dealt with that type of software before, you'll understand it's kind of a high technological requirement of entry. You got to be comfortable working with, in some cases, like command line stuff to get this to work. We can work around that today, but it's not the easiest thing to get into, but it's definitely fun. There's a really cool community around it right now. And it sounds great, and it's an amazing free tool. So let's jump into what we're going to use as our source tone. I've got a solo section here with some markers around it on this Legion roundabout cover that I did a Nail the Mix on back in 2020. So if you think this is ripping solo and want to mix it yourself, you can absolutely go check out that Nail the Mix. And I don't think this is the actual solo tone, but I've dialed up Archetype Plenty, which is one of my favorite plugins for solos. And I'm just using the Archetype plugin for the amp. And we're going to use the GGD Cali oversized for our cab tone. So I have noticed that at this point in time with Neural Amp Modeler, it does an excellent job of an amp-only tone and not as good of a job of a complete tone, meaning an amp and a cab in one model. So you'll get your best results right now just using an amp. So if you're using a real amplifier, that means you need to have a load box or some way to get a source directly from the amplifier that hasn't yet gone through a cabinet. It does okay at full tones with the cab too. And as I mentioned before, it's like very swiftly moving community. It's pretty fresh. It's a new plugin. It has a lot of attention on it right now, so things change, and it is vastly improving, being actively improved and worked on every day. But for right now, we're going to stick with the amplifier only. Let's hear it with the cab. that's with the cab. Obviously, if we turn that off and we just listen to the amps, it's going to sound terrible, but you'll know what we're getting into. So yeah, sounds like crap, just as any non-cabbed amplifier do. The next thing we need to do is to pull down our training file. If we go to the GitHub page, this is where you're going to need to go to download the actual plugin. And there are two separate GitHub pages, one for Neural Amp Modeler and another one for Neural Amp Modeler plugin. You're going to need the plugin first, so just find this on GitHub, download the latest release, which is version 0.7.3 as of the filming of this video. Just click on that, go down here, download the installer for your particular system. Pretty simple, nice installer. It also has a standalone mode, so you don't have to have a DAW loaded. We're going to go back on the Amp Modeler GitHub. Before we can get into anything, we need to download our training file. So if you scoot down a little bit, you'll find instructions on how to use Google Colab to train your model. We're going to use that tool. It's essentially a free tool. Google gives you a certain amount of time on a GPU machine. So it's like any machine with a GPU. This is a machine learning, uses GPUs typically. So if you have a system at home, you can certainly go down to the how to use local and set this up on your own system. You have to download Anaconda, create a Python environment. It's pretty involved. I mean, there are step-by-step instructions right here, but it's definitely the more involved method. But actually, we have a link for our version 1_1_1.wave file right here. And this is what we need to capture our tone. So you would click on this, download it, which we're not going to do because I already have it. And we're going to pull this in the DW in just a moment. But all the instructions on setting this up locally are here. And we're going to end up using the Google Colab method in just a moment here. But for right now, all we need is this specific file. And for this method, it does need to be this specific file, v1_1_1. So I already have a copy of that. And I've already brought that into the session. And if I turn off the plugin, it sounds something like this. So, as most modelers do, it sounds like some alien spaceship landing. It's got some ticks at the beginning and the end for calculating delay and whatnot. But we need to take this exact source and send it through our processing. So I'm going to turn back on our archetype, make sure things are at unity. I probably should double check my output because it seemed like it was a little hot coming out of the plugin. Okay, that should work for now. As long as you're not clipping, you should be good. The most current version of the amp modeling software, there is a normalization method. So while your model is being created, some volume information is encoded in that model and is fed back into the plugin. So there's a way to keep any volume differences at bay when you're skipping back and forth between different models. But for now, you just don't want to be clipping. And then one important thing is that NAMM is built to work at 48K and 24 bits. And the file that you spit back out into the trainer needs to be the exact same length. It needs to be those specifications exactly, 48K 24-bit, and the exact same length down to the sample as the version 1_1_1 file, because you upload both of them, and essentially some magical AI overlord looks at both files and devises a way to take any source from one to the other, if that makes sense. But they need to be the exact same length or the software will spit back out an error and you can't proceed. In Cubase, for some reason, it can be a little buggy. It will occasionally spit back out a file that's like one sample shorter or one sample longer. You just kind of have to play around with it. I will usually disable auto fade settings on this one track, and that I think sometimes helps. So we're going to do that now. Need to do it like this. There you go. Okay. And then I'm going to select this and process in place. Yep. And we're good to go. We're at Unity. We only have our amplifier plugin on. Let's render selection, channel settings, bit depth 24-bit, no zero tail, keep source unchanged, render. Okay, we have rendered out our amp. If you were using a real amplifier, obviously you would reamp like normal, split it down to a different track here, and then set your markers exactly around that original file and re-export your reamped track. So that's exactly what we're going to do right now. I'm going to call this amp. I think it's going to want us to rename it to something specific that I've forgotten at the moment, but we'll get instructions when we get to the training portion. So let's solo the amp track. Once again, make sure we're at Unity. I'm going to just bypass everything on my mix bus. That's also at Unity. So I have a key command to set my markers left and right around a particular object. So I'm going to select that our original 1_1_1_1_ file. Use that key command. So now I have my amp track and I have my left and right locators set to the exact start and end of the original reference file, which is that V1_1_1_1. I am going to solo the amp, make sure that it's at Unity. I have no inserts. My mix bus is all disabled. I could also just export directly from that track, but just to keep things simple here, export settings. We need to make sure that we are exporting a WAV file at 48K 24-bit mono, and then I'm going to leave all of this disabled as well. I don't want any extra XML data. You just need just the amp track. Let's start this process and ensure that is the same size after export. Okay, now those exports are completed. So we're going to head back to the GitHub page, scroll down to the Google Colab section and look for this link here. For the very easiest experience, open this link on Google Colab, and we are after the very easiest experience. Steps, get your data. We have that. Installation. Installation is when we install our training environment on this Google Colab, but we'll get to that in a moment. Metadata, train, results. Yeah, we still have to upload. So they curiously omit the upload section in the steps here. So yeah, first thing we need to do is install NAM into this Colab instance by running the next cell. So that's what we do. Click a button. Gives us some warning. Google may steal all of our data. Open credit cards in our name. That's fine. See some nerd stuff happen. It looks like we're good. So the next step is to upload here. I'm going to go to our files, and they do need to be named, specific names. It needs the original DI file needs to remain this v1_1_1.wave. The output file or your amp file actually needs to be labeled output wave. But what I would typically do is export it as something a little more descriptive, just for kind of my files, my references. In this case, I've labeled it amp, extremely descriptive. But we're going to upload it like that, which takes just but a few moments. And then we can just go ahead and rename the file in this instance of Google Colab. That way files in your computer can stay a little more organized with a name that actually tells you what it is. And for the purposes of training, you just rename it right before that step. So we'll go to amp, rename file, output. We have uploaded, we have installed our version of Neural Amp Modeler. I'm going to scroll down. This is a new section I actually haven't even used yet. The software is developing so swiftly right now that there's new things all the time. So there's now a metadata section in the actual models, which is very cool. I'm not going to worry about this too much. I'm just going to leave all this static for now. But if you're training a model that you want to share with your friends or upload to one of the different repositories, then absolutely fill out the tag data so things can stay organized. A few options here before we train. One would be the amount of epochs the training is going to go through. And essentially, an epoch is how many times it's going to try and prove itself. In one epoch, the model will look at all the available data one time. So it's like one pass. And then in the second epoch, it would start with the knowledge it gained from the first epoch and then try and improve itself. So each epoch is like a chance to get closer to the output from the actual AMP file and the output from the model being identical. 100 is a good place to start. If you're using the Google Colab, I think that takes about 15 minutes, 15 or 20 minutes. It's a pretty similar when I have done it locally on my plebeian 1070 card. So obviously you need a video card that contains CUDA cores, I believe is the actual requirement. So on a 1070, it's pretty much similar to what you get with a GPU model here on Google Colab. If you have a faster card, then absolutely go through the process of running this locally, and you can whip these out really quick. Regardless, 100 epochs about 15 minutes, and they seem to be linear if you're using that same V111 output file. So we're going to stick with the 100 now. I have seen diminishing returns around 600 to 800, depending on the complexity of what you're trying to model. Like if you have just an amplifier and no cab, you'll probably find with just 100, you'll probably get close, or as close as you're going to get. If you have maybe a boost pedal in front of the amp, or it's a boost pedal and an amp and a cab, maybe you want to go to 400, 500. If you're trying to model some mix elements too, like EQ that you have in your DAW in your mix project, then maybe go even higher. But really, it seems to top out at around 1,000. After that, you're just kind of wasting energy. The second option you have is the architecture, standard, light, or feather. And that determines how much CPU you will use when you're running the model later. So the standard architecture is pretty CPU intensive, honestly. It's gotten better with a few updates recently. But if you know you're going to need to run this on a low-powered machine, or if you're going to want to be able to turn your buffer settings way low so you have minimal latency, then maybe you'd be better off running a light or a feather model. Perhaps you're creating a model of just a boost pedal. That's a pretty simple model. Then maybe light or feather would be better, since it's going to be stacked on top of an amp and it doesn't need anything more than that. But we're going to stick with standard for right now. That's actually all I've done. It's just standard models, just learning the software. So we're going to leave everything as default. Now that we have our files uploaded and named properly, we have our settings set here, and we have irresponsibly skipped the metadata section. Let's go ahead and start the training process. So the first things it's going to do is calculate a delay. And I just kind of let it do its thing, even though I'm not always positive it's 100% correct, because the delay should be compensated already in my bounce. But then you can kind of see it going through its process down here. Like I said, for 100 epochs, it'll take about 15 minutes. After a few epochs, you can go into your file section. Here we go. You'll see a new folder pop up called Lightning Logs. And if we go into there, version 0, if you're training multiple models with the same instance, you'll have a version 1, version 2, etc. If we open that and then open checkpoints, let's extend this a little bit, you can see each epoch step and what's called an ESR. The closer your ESR is to 0, the more accurate your model will be. You can kind of watch here and check the process. And the idea is that it'll pretty quickly get down to about 0.1. And I think at some point over here, it will give you, no, I guess it shows you some information after your modeling is completed. But yeah, you're looking for a lower number. So you can kind of watch progress in that regard and just watch your ESR get hopefully lower and lower. So now we're already down to 0.07. You can see at step 8, we were at 0.09, and 14, we're at 0.076. So it'll continue to improve itself. And we'll let this run for about 15 minutes and check in after. Okay, so it looks like it's finished. It reached the all 100 epochs, and our ESR is not super great. Oh, there you go. ESR stands for error to signal ratio. You're looking for something as close to 0 as possible. We have 0.0467. It's not terrible. It even tells us right here this might sound okay. I'm pretty sure why we have a little bit of a suboptimal output. But anyway, this is a screen you get. It shows these two lines, which I'm not exactly sure what that's supposed to signify, but obviously you want them to be closer. One is the target, which is your output file, and the prediction is what the model spits out. And you can see there's some variance here. But if we jump back in the project, I dug around in that patch a tiny bit and realized that I have this compressor engaged. I also have this overdrive, but it should be able to handle the overdrive, but since the compressor is a time-based effect, it's probably throwing some error in there that the model is not able to compensate for. So I'm going to download this model, and we'll save it, and then I'm going to rerun the training process with this compressor disabled and see if we can improve that ESR just a bit more. So I'll go through all that off-screen with the power of editing. We shall return with a newly trained model that's hopefully more accurate. All right, so we just finished our second training and definitely achieved a better error to signal ratio. It's still not amazing. I've seen people in the community get these scores down really low, specifically using plugins since there's so few variables to worry about there. But I still expect this to sound pretty good. So you can see our little target and prediction graph is a little more aligned now. This is going to end up being pretty close. So we're going to go over here to the file section under exported models. I've already downloaded that first one, so we're just going to go to version_1 and download. And I labeled the first one model with compression, and I'll just with compressor, and I'll just leave this one model. So now we have both for comparison purposes. Let's get back into our project. I'm going to disable some of the tracks we use to output the amp information and get back over to this little chunk of shreddage. Do a quick save and duplicate this track a few times. NAM and NAM with comp. I'm going to turn back on the cabs for all of these and then obviously remove the archetypes. So we open our neural amp modeler, going to select our model. This first one is the regular model, and then copy it over here and just switch this one out for model with compressor. And we're gonna leave everything stock for now. We may have to make sure that input levels are even. We may have to do some volume normalization. We can always use the EQ to get closer if it needs any further sculpting. But let's just see how close we get with these straight out of the AI training. Make sure our routing is in place. Yeah, these are all kind of going back through our full signal path here. So let's see, I'm gonna start with the original tone and move to the tone which should sound hopefully best. Doing this totally blind, I have not listened to this one yet. So hopefully it's not real wacky for whatever reason. And then we'll try the one with the compressor and see if we can discern any differences between those two. Let's make sure that the compressor is still disengaged here. Okay, yes it is. Okay, let's see. So it feels like it maybe has a tad less gain. Let's add 3 dB. It sounds pretty identical. Realizing again that another thing I should have probably disabled on the archetype would have been the built-in gate that I did have up, because I'm hearing more noise in our model. That's probably one thing that's throwing the modeling process off even more. I typically wouldn't model a plugin, so there's a few things that don't really apply to a real amp. Most of my amps don't have built-in gates. But yeah, that probably would have been a move, is to turn that gate off and really strip it down as much as possible. If you are making a model of a software plugin, then just go through and make it as simple as possible. Make sure there's no hidden settings like this gate that I forgot about until literally right now. But despite that, it sounds essentially identical. Like maybe I could tweak the EQ and really tweak the gain station to get it right in the right spot. But in the context of a mix, when you're going to be mixing this tone anyway, pretty identical and for free. To me, the main benefit, aside from it being free, is the fact that you're able just to take that V111 file and reamp it when it's convenient for you to reamp, like when you're reamping. And then later on down the road, when you have more time and maybe when you don't have artists in the studio and you're working on tones, you can take that time to, okay, let's cut up my files, let's upload to Google Colab and get that process rolling. I really like being able to just do the reamping part when it's convenient in my process and make the models later for archival purposes or for whatever reason you want. But just to see what the difference is between those two models, the one with the compressor, let's see how close they got. So I've already added 4 dB of gain. I imagine this one will be similar, although the compressor could be altering the gain structure. But just to keep things even for right now, let's make these the same and listen to the same clip back and forth. again, it's really close. So even with an ESR of 0.04 something, I believe, where we were even getting a warning from the modeling software itself, it sounds really close. This is completely usable. In some regards, it might even be closer. I feel like maybe the attack characteristic of this is even slightly closer to the original. And in many cases, it's just simply indistinguishable, which is pretty cool. So you can make a tone, share it with your friends, and you have these convenient name files. They're easy to share. They're easy to store. There's a pretty active community on Facebook. I think it's like the main community. Just search for Neural Amp Modeler and find the group. I think recently it just eclipsed 10,000 members or something like that, with a good amount of them being active. There's also a really cool website called tonehunt.org that is associated with NAMM, but it's not built by Mr. Steve Atkinson, who is the wonderful creator of both the modeling software and the plugin itself. It is open source, and there are multiple collaborators now, which is really cool. You can even see what's changed in the most recent version here. But ToneHunt is a really cool site that's only been up for under a month, I believe. And they're already at, over 4,000 different models. You can find a lot of cool stuff. I'm honestly pretty new to all this too. I just find it really fascinating. I wanted to share it with you guys. But I found that once you find a model that sounds good, maybe stick with that creator and check out their other models. It's similar as it would be to the Kemper profiles, where there's definitely a skill to crafting these models. I haven't quite gotten there yet. I've just barely gotten to the process where I can go through the entire thing start to finish and get something usable. But there are some fine tuning you can do and some parts of the process that I could pay a little more specific attention to increase your ESR, or rather reduce your ESR, and get even better models. But even with my, just like sort of fumbling through it like a bear, we managed to get a lead tone that is essentially indistinguishable. And it's all free, and it's all open source, and it just seems like the community is really cool and really nice. And I believe there is a good amount of crossover already with the URM community. So you will probably recognize some familiar faces. It's a cool thing. It's pretty fun. It's sort of neat to get in on the ground floor of something like this. It's so community-based. I think it's using essentially the same technology as the ToneX plugins do. So you can achieve similar results there, but with a little more control. I think it's pretty neat, pretty fun. Thanks for watching.